Fellow folks, Chapter 10 deals with something called conic sections. This should not be new to you. You have dealt with conic sections back in geometry and in Algebra 2, so this should be very, very, very familiar, and hopefully that also probably means on the easier side. So basically, what these mathematical ideas come from is if we take two cones that are stacked on top of their vertices like this, and we intersect those cones with planes, we can end up with 4 different scenarios. You can end up with more, but 4 that we mainly study. First is if we intersect the cones such that the plane is parallel with the circular base, then we end up with a circle. If we intersect the plane with the cone at an angle that's not parallel with the base, then we end up with the shape of an ellipse. And if we intersect it again at an angle, but that also goes through the actual base, we end up with a parabola. And then if we intersect it so that the plane intersects both cones, we end up with a hyperbola. So these are the conic sections. 10.1, section 10.1 dealt with very, very basic ideas with distance and midpoint formulas, which you're pretty well versed in by now, so we're skipping 10.1. We're just jumping straight into 10.2 with circles. So by definition, a circle, by the way, you don't need to draw these were just for your reference. A circle is the set of all points in a plane that are equidistant, which that equidistance that we talk about is the radius from a given point. That given point is the center point. You can go ahead and just sketch this and maybe even define this. You can shorthand it though if you'd like. But this is important for you to understand and be able to generate but what definition of a circle is. And then so basically when we use that word equidistant, it has an equal distance. If we consider our distance formula, which we used a bit in our vector unit, the distance formula was d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. If we manipulate the distance formula slightly to mold it to the scenario that we have of a circle. So here, let me explain these variables. Our center point of a circle is given by the coordinate hk. R clearly stands for the radius. XY just stands for any point on the circle. So if I refer to that distance as R, and then I square both sides, then I get the standard equation of a circle. Standard equation, which would be, and I'm just going to switch the order as well, because we typically see it as x minus h squared plus y minus k squared is equal to r squared. This is the first big takeaway from today. Hopefully this looks extremely familiar to you. This is the standard equation of a circle, and in case it was not already made obvious, the center point is given by the coordinates hk, and radius is a little bit more obvious. It's just given by the variable r. So our first example, I want you to write the equation of a circle that has a center point of negative 5, 2, and a radius of the square root of 10. So again, you can abbreviate these questions if you like, but definitely make sure you at least write them down in some fashion. That way you can relate your future questions that you'll see throughout not only this homework, but just throughout the whole unit when you're going back and looking at notes if necessary. So if I define my center as hk and I know my radius is r, then I literally have given you all the information that you need. So you're literally just going to substitute these 3 values directly into our standard equation. Open parentheses, x minus, instead of h, we're substituting in negative 5 squared, plus y minus k is 2 squared, is equal to r squared. So r is the square root of 10 squared. And then before you call this your answer and call it a day, you definitely want to simplify it a little bit and clean it up. So you get x plus 5 squared plus y minus 2 squared is equal to the square root of 10 squared is just 10. So that's as basic as the circle questions get. I give you the center, I give you the radius, you plug it in and simplify it. Now, I might also give you something a little bit more challenging where I give you some of what you need to know, but you have to find the rest. So in the second example, the directions say, write the equation of a circle that's tangent to the x-axis with the center point at -3, 3, -2. Center point at 3, -2. So the center point is half the battle, and I give that to you. That's h and k. But when I tell you that it's tangent to the x-axis, you got to remember a couple things. I don't want you to think about sine, cosine, and tangents. This tangent, when we talk about circles, refers to a line that intersects the circle at exactly 1 point. Intersects the circle at exactly 1 point. So what I want to do, and I should add actually to this question, I want you to graph this, I want you to write this equation and graph it. So let's at least go ahead and graph the center point. 3, -2, we know that's our center point. Now, when it says our circle is tangent to the x-axis, so if this is a center point, we could have a circle like this. Now, this doesn't intersect the x-axis at all, so it's not going to be this small. This circle is too big because it intersects the x-axis twice. So if my circle is going to intersect the x-axis only once, the only way that that's possible is if it intersects the x-axis right here at the point 3, 0. In other words, the radius is going to be the distance from the center to the x-axis. And if that's the case, then you literally just count the distance, 1, 2. So that means r is equal to 2. So you already had hk, you now have r, and then we're just going to plug this into the equation of a circle. X minus h squared plus y minus k squared equals r squared. So we'll have x minus h is 3 squared plus y minus k. Well, k is -2, so that's going to change to y plus 2 squared equals r squared, which is 2 squared, which is 4. So there's the standard equation of a circle. And I also asked you to graph it. So we have the center point here. And basically, anytime you graph a circle, you want to graph your center point, and then you want to graph the radius in 4 directions, up, down, left, and right. So I've already graphed the radius going up 2, but also graph it to the left 2, down 2, and right 2. And that'll give you the estimation of where the curved part should be. And it's okay if your circles end up looking like eggs. Just do your best to at least make them go through those 4 points. Okay, so those are the pretty basic types of questions. Things, of course, will get a little bit more complicated because, as is with equations of lines being represented in different forms, there's another form for the equation of a circle, and it's called general form. So standard form is the nice form because everything is visible. It's kind of like slope-intercept form of a line. You see the slope, you see the y-intercept. General equations of lines, standard equations of lines are not as easy because they don't tell you what you need to know. Similarly with general form, you get x squared plus y squared plus dx plus ey plus f equals 0. So this is the second big takeaway, the general form of a circle. And before we do this example, we need to define a couple of things. So the first thing I want you to notice is the leading coefficients for x squared and y squared must equal 1 So in general form, x squared and y squared coefficients must equal 1. And additionally, d, e, and f are just integer constants. Those are just constants. So the next example we're going to do like this is I want you to write the standard form of the equation and then graph. And that equation that I'm going to give you will be 2x squared plus 2y squared minus 4x plus 12y minus 18 equals 0. And what I want to do is, as I walk through the problem, I'm going to write my steps on the right side. Like, even though I'm voicing over this video, when you look back at your notes, it's good to kind of know, okay, why did we do that? Where did this number come from? You know, how did this come next? That kind of thing. So anything that I do, I'm going to write the wording out to the side. So the first thing that we want to do is get our leading coefficients, those x squared and y squared coefficients, equal to 1. Get x squared and y squared coefficients equal to 1. And in order to do that, it's actually going to be really easy because both of them are 2 right now and all of these numbers are even. So if I divide everything by 2, then I end up just with x squared plus y squared minus 2x plus 6y minus 9 equals 0. And that simplifies things pretty great. And then what you want to do after you divide everything by 2 is we want to group our x's and y's. Because what's going to happen is, in order for me to notice, I have lots of stuff going on the left side, nothing going on the right side for what I know is going to eventually be the radius. And notice that in the standard equation of a circle, which is what I'm trying to get it into, there are no just x and y terms. You only have something squared. So what we're going to think back to is our factoring days. And what we want to set up is completing the square. Group x's and y's to set up completing the square. So what that'll look like is this. That'll be x squared minus 2x plus, we don't know what that number is going to be. It's going to be the new c, plus y squared plus 6y plus, we don't know what that new c is going to be, is equal to, and then we're going to move that negative 9 to the right side. So you group your x's and y's, and additionally you move your constants to the right side. And then we're actually going to complete the square. So brownie points if you remembered how to do this without me having to say this next part. But completing the square, when I find that new c, that's found by doing b over 2. Well, let me write this over here. Your new c is found by doing b over 2 squared and add to both sides. So find b over 2 squared and then add to both sides. So for this group of x's, b is that negative 2. So we'll do negative 2 over 2 squared. And then there's benefit to simplifying one step at a time. Negative 2 divided by 2 is negative 1 squared. Negative 1 squared is positive 1. So that's the completing the square for the x's. We do the same thing for the y's. B divided by 2 squared. So that's going to be 6 divided by 2 squared. 6 over 2 is 3. Squared is 9. Okay, so let me kind of regroup what that would look like. That would be x squared minus 2x plus 1 plus y squared plus 6y plus 9 equals 9 plus 1 plus 9. So these 3 digits, well 4, well I guess kind of 2 technically, this 1 and 9 was added to both sides. These were our new c's. Now, in doing so, when we actually finish completing the square, we end up factoring these trinomials. So what that means is this trinomial can be rewritten as x minus 1 squared, and there's the benefit of the middle step. That minus 1 is just b divided by 2. You could literally just drop that right in. Same thing with this. Y squared plus 6y plus 9. Yeah, you can figure out what two numbers multiply to be 9, add to be 6. Or we can just drop in this b over 2, which we knew was a positive 3, and just do y plus 3 squared. And then 9 plus 1 plus 9 is 19. So this is the first step of your answer. That is the equation of the circle in standard form. Now, in order for me to graph it, I've got to know what the center point and the radius is. So to do that, my center point is going to be h and k, and it's kind of going to be the opposites of those binomials. So instead of, if it's x minus 1, I know that x value, or the h value rather, is positive 1, and then y plus 3 indicates negative 3. So my center point is at 1, negative 3. Let's graph that first. And then 19 is r squared, which implies that the radius is the square root of 19. Now, obviously 19 is not a square number, so when that happens and you actually have to graph, you just need to estimate where that is. The square root of 19 is going to be approximately 4.4. So that means starting at your center point, in each direction, up, down, left, right, you want to go approximately 4.4. 1, 2, 3, 4. So it's almost 4.5. It doesn't have to be perfect. One, two, three, 4. And then the best way to draw a circle, by the way, instead of trying to connect all 4 at the same time, is to draw 2 semicircles. So think about connecting one point, going to the top, stopping there, and then do the bottom semicircle. Sometimes, it didn't work out as great, but sometimes that's better than trying to do the whole circle in one motion. So there's that circle going from general form to standard form. Okay, another type of question you may see will sound like this. Write this standard form, and you could abbreviate standard form to SF and general form to GF, however you want to do it. Okay, I want you to write the standard form of the equation of a circle that passes through these points. 1, negative 1, 5, 3, and negative 3, 3. Then identify center and radius. So I want you to think about what this means. 2 points determine a line, right? So there's point slope form of a line to kind of figure out what that might be. 3 points determine a circle. So this one's a little bit tricky. So the idea, what you need to do to solve this kind of question, is we're going to substitute each ordered pair into general form, and we're going to make a system of 3 equations. Okay, so we're going to substitute each ordered pair into general form. So the general form, you don't have to rewrite this. I'm just rewriting it for the sake of the video, but you can if you want, is x squared plus y squared plus dx plus ey plus f equals 0. So we're going to substitute each of these 3 points into this general form, and we're going to set up a system of equations. So let's do that. The first point is 1, negative 1. That means everywhere I see an x, I'm plugging in 1, and everywhere I see a y, I'm plugging in negative 1. So if I plug in the point 1, negative 1, that implies the equation x squared will be 1 squared plus y squared will be negative 1 squared plus dx, that'll be d times 1 plus e times y is negative 1 plus f equals 0. And you could keep simplifying this right here. I'm going to kind of simplify all three equations after I plug them all in. So I'm now going to substitute the point in 5, 3. So that implies the equation 5 squared plus 3 squared plus dx will be d times 5 plus ey will be e times 3 plus f equals 0. And then the last point, negative 3, 3, implies x squared will be negative 3 squared plus y squared will be 3 squared plus dx will be d times negative 3 plus ey will be e times 3 plus f equals 0. So literally all I've done was I've plugged in these values for x and y into the general form. And then what we want to do is you want to simplify this all again. So I want to simplify the three equations. Okay, and in doing so, I want to get the d, e, and the f terms on one side, and I want to get the constant on the other side. So if I do that, let's actually just go ahead and square everything first. So 1 squared is 1, plus negative 1 squared is also 1, plus d minus e plus f equals 0. So that's simplifying the first equation. Simplifying the second equation, 5 squared is 25, plus 3 squared is 9, plus that'll be 5d plus 3e plus f equals 0. So there's the second equation. And then the last one, negative 3 squared is positive 9, plus again 3 squared is 9, minus 3d plus 3e plus f equals 0. So maybe I should keep these grouped. So there's our system. Here's it after simplifying once. And then we want to simplify it again by getting our constant to the right side. Okay, so I want all the d, e, and f terms to be on the left side. So that'll be d minus e plus f equals, that 1 plus 1 will end up being a negative 2. Then 5d plus 3e plus f equals, that'll be negative 34. Then negative 3d plus 3e plus f will equal negative 18. So then what you have here is a system of equations. And in order to solve this, you could do it by hand. It would take you forever. So we're going to think back to what we did at the very beginning of the year, where we can solve the system in our calculator using a matrix. So that's what your calculator is for. So go ahead and take out your calculator if you haven't used it yet. And again, I'm going to write down the steps of what you need to do for you to refer back to later. So in your calculator, what you're going to do is hit second matrix. Matrix is on the like invert or x inverse button. It looks like x to the negative first power. So when you hit second matrix, it's going to take you to a screen, and probably you don't have any matrices saved in there. So then what you want to do is you want to scroll over to edit, and then just for the sake of the video, we'll just all edit the first one, which will be matrix A. So then click enter. Enter when you click matrix A. Now, when you enter in matrix A, what we've got here, and let's go ahead and write this matrix first. When we write this augmented matrix is what it's called, you take your coefficients and you end up with 1, negative 1, 1, negative 2, 5, 3, 1, negative 34, negative 3, positive 3, 1, negative 18. So this is our augmented matrix. So when I enter this in the calculator, it's going to be a 3 by 4 matrix because it's however many rows we have by however many columns we have. So then I'll give you a second. Go ahead and enter that into your calculator. 3 by 4, enter in the coefficients. And then what you want to do after you enter in these values is you want to go back to your home screen. So however you want to do that, where you want to hit second quit, or I think you can just hit clear and it'll escape you out of there. But go back to your home screen. And it's important that you get out of the edit function. So when you go back to the home screen again, you can just do second quit if you need to. What we want to do is you're going to hit second matrix again. And then in order to actually solve the matrix, you are going to scroll over to math. And then you're going to scroll either up or down. It doesn't really matter. To RREF, which is reduce row echelon form. And then you'll hit enter. And that'll enter in RREF on your home screen. So then you need to hit second matrix again. And then hit whatever matrix you have saved. In this case, we did 1 matrix A. So then you'll enter in matrix A. And then you'll hit enter one last time. And then it should actually calculate the reduced row echelon form of matrix A. In doing so, your screen is going to show you this matrix. 1, 0, 0, negative 2, 0, 1, 0, negative 6, 0, 0, 1, negative 6. So what this means, if you didn't do this, by the way, I can't really pause the video for you, but make sure somebody gives you assistance with that later, or I can help you when the video is over. These values, because we have our identity matrix here to the left, these values are your values for D, E, and F. So this indicates D is negative 2, E is negative 6, F is also negative 6. Okay, so what that means is we can go ahead and write down the format of x squared plus y squared minus 2x minus 6y minus 6 equals 0. Okay, now if you go back and look at the question, it says write the standard form. So this is still the general form. So then in order for you to get it into standard form, you're going to do what we did on the last problem. You need to go ahead and continue completing the square. So we'll probably do this one a little bit faster. To complete the square, I'm going to group my variables, x squared minus 2x. I'm going to leave space for my new c, plus y squared minus 6y, space for that new c, equals, and then I brought my constant of negative 6 over to the other side. Okay, so to find these new c's, I've got negative 2 over 2 squared. Negative 2 divided by 2 is negative 1 squared, which is positive 1. So there's this new c. I'm going to add 1 there, and what I do to the left side, I've also got to do to the right side. And then we can find the new c for the y's. That'll be negative 6 over 2 squared, plus negative 6 divided by 2 is negative 3 squared, which is positive 9. And we'll add 9 here and add 9 to the right side. And then the purpose of completing the square was so that we could rewrite these as perfect binomials squared. So that'll be x. Again, you can focus on these b over 2 values and just drop those straight down. That'll be x minus 1 squared plus y, bring down the minus 3 squared, equals 6 plus 1 is 7 plus 9 is 16. So there's the first part of your answer. And then the second part was after you switch forms to tell me what the center and the radius are. Well, again, the center is going to be the opposite signs. So instead of x minus 1, that means h is actually going to be positive 1, k is positive 3. And then the radius, if r squared is 16, then the radius must be 4. So that's the lengthiest question that you're possibly going to have because it incorporates all of basically the different types of things that we have even talked about by circles so far, both standard and general form. The only thing you didn't really talk about was something being tangent, but that was the most complicated. The last kind is going to be another pretty simple type of question. It's going to say to write the equation. Just a little bit bigger. Okay, I want you to write the equation of a circle that goes through the point 1, 5 and has a center at -2, positive 1. So this one's similar to the last question because I'm telling you it has to go through a particular point, but it's not defined by 3 points. And in fact, I give you, again, half the battle. I gave you the center already. 2 things determine a circle, a center point and a radius. Well, you have a center. The only thing that we need is the radius. Okay, but I give you another point. So if I use this point as an x and a y value, and I use my standard form for the equation of a circle, which is x minus h squared plus y minus k squared equals r squared, then I can substitute in these 4 numbers to solve for the radius. So if I do that, instead of x minus h, I'm going to have x is 1 minus h is -2 squared plus y is 5 minus k is 1 squared equals r squared. And then we just got to simplify this. So 1 minus -2 will change to plus, so that'll be 3 squared, plus 5 minus 1 is 4 squared equals r squared. And this is a Pythagorean triple, or if you can't see that, 3 squared is 9 plus 4 squared is 16 is 25. And 25 equals r squared. Now, technically, you could solve down to actually get r if you wanted. But the standard form of equation of a circle is solved for r squared. So that's really where you can stop your solving because you already have hk and you have r squared now. So that means your final answer will be x instead of minus h will be minus -2, which will change to plus 2 squared, plus y minus k will be y minus 1 squared equals, and then r squared is 25. And then that would be your final answer. I realize now I didn't specify which form you needed to write it in, but when in doubt, if given the choice, this standard equation is typically going to be much easier than the other one.